Okay, this video is for 9.3a, quotient properties of exponents. So, the last few days we've talked about multiplication properties of exponents, we've talked about zero and negative properties of exponents, and today we'll talk about quotient properties of exponents. And it all works similarly with kind of the other stuff we've been doing, but there are just a few differences. And as you can see, a lot of these can get pretty complicated as well. Let's do a couple from this page and a couple from the back side. The big thing to be aware of when we are dividing exponents rather than multiplying them is that we want to subtract the exponents now. So when we were multiplying exponents, we always added them together. Now that we're dividing them, we're going to do the opposite. We're going to subtract the exponents, but the bases are going to stay the same. So, for example, number 3. We have x to the 4th and x to the 9th. The base of both those terms is both x. So we leave x the same and we subtract the exponents. So this becomes x, and then 4 minus 9 is negative 5. So one answer is x to the negative 5th. But again, like we talked about yesterday, we don't want to leave our answers with negative exponents. So now that we have one, we need to drop that term to the denominator of a fraction and change the negative exponent to a positive. So now the answer for number 3 is 1 over x to the 5th. Sometimes you don't need to do all that. For example, number 4, they have the same bases again, x, and so our answer is going to have the same base, and then we subtract the exponents. 9 minus 4 is 5. Since we do not have a negative exponent in this answer, this is our final answer. There's nothing else we need to do. Now, let's complicate it a little more. One other thing to remember, and number 9 is a good example of this. If you have an actual number, for instance 4 to the 11th, which is a number, it doesn't have a variable in it, and you have another number which doesn't have a variable in it, you're going to divide them like normal. This bar here is a division sign. And so actual numbers without variables, you just perform division like normal. 4 to the 11th divided by 4 to the 11th, well, that's one number divided by itself. So these two actually cancel each other out and become just 1. So once we do that, our problem simplifies to x squared divided by x to the 5th. And now we have two of the same bases, which is x, raised to different exponents. So we subtract the exponents again. X squared divided by x to the 5th becomes x to the negative 3rd. Now we have negative exponents again, and so we drop that to the denominator, and this becomes x to the positive 3rd. And 1 divided by x to the 3rd is our final answer. All right, let's look at a couple more. So, let's take a look at 16. Just like when we raised a product to a different power and we distributed that power into both numbers, we do that as well on our quotient rule. So what we want to do here is take this 5 that's outside and distribute it to both of the terms. And by distribute it, I mean multiply the exponents together. So we have x to the 5th divided by y squared, and then that whole quantity to the 5th power. This will then simplify to x, and then 5 times 5 is 25, divided by y, and 2 times 5 is 10. And this is our final answer right here. Now, on the back side, there are some complicated problems. Let's do just one of these, and then see if you can practice and get the hang of it yourself. So, number 19. First thing to look for, so we want to simplify all these terms. You can see that we have a big exponential term within parentheses, and then that whole thing raised to the power of 7. What we want to do is simplify what's in the middle of the parentheses first, and then distribute the 7 afterwards. So first thing to notice, we have a 9 out front on the top and a 3 out front on the bottom. Those are just numbers. There's no variables associated with them, so we want to divide those numbers. 9 divided by 3 is 3. So a 3 goes on the top. Now, take a look at the next one. Look at the two terms that each have an x variable in them, x squared and x squared. We're going to divide these since we are dividing these terms, and since they have the same bases, the base stays the same, and then 2 minus 2 is 0. We'll deal with that in a second. Remember yesterday, when we raise something to the 0 power, it just becomes 1. We'll deal with that in just a second. Now look at the next one. We have y and a y, so we do 16 minus 7, and that becomes y to the negative 1. Two things to do moving to our final answer. The 3 stays there. X to the 0 is 1, so we'll just remove it. And then y to the negative 1 needs to drop to the denominator and become positive 1. So 3 divided by y to the 1. And then the last thing, we need to distribute this 7. So our final answer is 3 to the 7th divided by 7 times 1 is y to the 7th.